Let's solder this one up and then I'll see if it works. The Starblinken project. If you haven't seen it, I'll put a link in the description. We need 3 of the IC sockets. So it's 3 here, 3 here. Oh. Okay. So that happens way too often. I started with the parts where I knew I just have 10 off, and then I just put everything in here. So I have parts for 8 kits. Sorry, 7 kits, because I wanna solder up 1. I've got my parts list and it's not much to it really, so I'll just pack up whatever I have to pack in there. What do we have here? It's a 47K resistor. I only need 1 per pack. Just going to cut them off. I don't want to lose anything that I have put on the table from the 7th kit that I want to solder up. I have this box with through-hole components that grew a bit over the years. I might need to get a bigger box for the through-hole components and maybe sort some parts. The 470 ohm resistors are for... there it is. Those are for the LEDs. We need 10 resistors. Do I see that right? How many resistors did I buy? 200. It's reasonable to get a bunch of 470 ohm resistors. Check again, 10. Check again, 10. That's a 2K2. That takes a while. So out of this LED bag of 500 LEDs, I've made little packs of 40 LEDs and then put 2 extra on top. I mean 42, isn't that awesome? It's just for good measure. Maybe 1 LED is broken and someone is annoyed by that. We don't want that. I forgot some sockets and they are behind this wall of PCBs. So. But yeah, that's everything for the parts. I need to make a picture, a before kit picture for Tindie, and then I'll need a picture of the thing working. So that's why I'm soldering up 1. So that looks good. That's my product photo. Look at all the mass around it. I was about to say, let's start with the sockets, but I should really start with, turning on my soldering station. Oops. The sockets are in, so I've added 100 NF nanofarad capacitors to the kit for stabilization, decoupling the chips. It's relatively easy to spot where the capacitors have to go. It's always on the outside. Now we have to snip off the legs of the capacitors. So let's do that. Sorry, I shot my camera, but I didn't shoot the deputy. Oh no. Okay, I was about to be angry at myself that I didn't mark the resistors very well, but I actually did. It's on the back side. So for 47K, that should be manageable. There are 2 resistors in the kit. One is a 2K2. That's just easy to spot because 2 is red and every line of it is red. And there's the 4K7 resistor. Oh, that's not even the right PCB. We are here. Leg 1, leg 2, leg 3 and leg 4. Oh shoot. Don't do that. Okay. I ripped off the ground pad. Or I ripped off the resistor from the ground pad, but that shouldn't be much of a problem. Potentiometer needs a bit of force and rotation and wiggling. Then it's in. Off camera I've soldered up the resistors of the capacitor. So I'm gonna put in the ICs now because I want to test if the LEDs are in the right way. Let's bend the ICs so they can fit the IC socket. The 4017 goes up in the top right corner, and there's the 555 timer, top left. And the bottom two are the ULN 2003s. Interesting. All chips on here are Texas Instruments chips. Well, this one looks fake. The 555. What can you do? Let's try 5 volts. There we go. Already prepared. Ground. VCC. Nothing happens. Maybe I really need more power. Let's try 9 volts. Oh. Okay, I forgot about an important detail. There is the socket for an external clock. So you can take your synthesizer sequencer clock and put it in here. Yep, but I have to connect the socket first. So that's a thing. Okay, so I thought I broke it again, or it still doesn't work, but it actually should if I pull out this cable. And it doesn't. I turn it up. Nope. Let's try one more thing. Oh. Yeah, it should really check the cables of the power supply. Nope. Let's try a higher voltage. 9 volts. Come on! That's my lamp. Don't worry. Ouch, ouch, ouch. It gets really hot. I have no idea what's happening, and I will continue this tomorrow. I've decided on soldering up the whole thing and then test again, because I wasn't able to find anything. I beeped it through, and oh yeah, that was stupid. It's running in. Can you see that? No, you can't. Oh, did I kill it? Okay, I probably just killed it by turning the knob. I'm an idiot. If you have it in current mode and then you switch it to anything else, you might break stuff. Oh, there we go. Oh, I broke the multimeter, didn't I? What? I know you might be thinking, oh, it's in the wrong thing here. No, it's not. Milliamps, microamps is here too. Yeah, it does work. Whenever you're measuring amps, don't turn the dial of your multimeter. I'm not burning my fingers on the 555 timer. I have no idea what happened there. I checked everything and everything makes sense. I've rechecked the schematics. I've compared them to the MIMS 555 timer basics, and everything checks out. I think what's important to show is the external clock. Okay, so the first thing we gotta do is plug in the cable. So, and also let's grab a socket. Ooh. Now it's floating. Why is it floating? It's basically an antenna now, the cable that I have on the input pin. Negative, plus, negative, plus, negative, plus. Okay, so you can use this to show the external clock, just don't have it floating. That's the Starblinken. And I will put this on Tindie very soon, so hooray me! I made it! I have no idea how to repair the milliamp section Maybe it fixes itself after a while. Maybe it has a self-resetting fuse somewhere.
I'm pretty sure this is a continuation of my obsession with
these nuts. Got him!